today we will talk about relational databases and the whole principle of the databases. And during three other lectures, we will talk about the SQL, the special language to communicate with the database, to manage the database, to create the database, to gather data from the database, and so on. And for today, we have this relational database thing. The first question for you guys. I heard about your quiz completed, but I'm not sure that everybody completed the quiz and everybody read the textbook. So the question for everybody, do you have a chance to read the textbook and to understand the material?
Yes.
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 Okay, that's absolutely great. So I will rephrase the question. Do we have somebody who didn't have a chance to do it? Okay, seems that everybody is great. Everybody did a good job. And to check if you understand the material well, I would like to begin with questions to you. If something is not very understandable from the textbook, we could try to discuss it right now in the class. So the first question is, what testers' tasks demanding database knowledge may you list? Who can tell me? Anna? Raising hand. Alona?
Hello. Testers task maybe this to find data for plant test, to add data before plant test, and to remove data and see what happened after it from database.
Thank you. Thank you. This is more or less true. So to sum up, tester is doing something with the application, and the application has a data, yes, and from time to time, it is needed for a tester to prepare some test that demands changing the data or searching the data in the database, or even deletion some data from the database. And that's why it is absolutely mandatory for a tester to know how to do it and to know what is all that thing about what our database looks like and so on. So that's why we need that knowledge. Absolutely true. So who can answer me to the next question? Is Excel or other sheets convenient for storing data? Maybe you can imagine why is it convenient or not, or why is it not convenient? Who can tell me that thing?
May I?
Yeah, sure, Dmitry.
I think it's not convenient because to work with this data, it needs more time. That's why Excel sheets is inconvenient, I think.
Does everybody agree with Dmitry? Gigi?
Let me.
Gigi was the first one, Nikita, sorry. Ladies first.
No problem.
Yeah.
Oops, sorry. You can finish, Dimitri. It's okay. I just have a little more opinion about the question number 2.
Okay.
So,
please share your opinion.
Yeah. I think Excel is not that bad for storing the data if the data is like a small data. and it's easy to manipulate, and it saves cost for the company. But if the company have a big data, like very, very big, they're gonna need another tool to store the data. It depends on business size, let's say. Yeah.
Yeah, absolutely. You're absolutely right. Just thank you. Nikita, your turn.
Thank you. I'm just wanted to tell that probably Excel is much more convenient for human, but not for machine. Just because in support of words of Gigi, that if we have a lot of data, it's hard to make some change, for example, or check any mistakes which could appear. So let's say storing in database, it's much more convenient for machine which use some ID like a reference to other tables and storing data.
Absolutely. Maybe somebody wants to add something to this.
In Excel, a lot of duplication of data maybe, or also it depends how organized Excel tables. It may be normalized or not.
Yeah. Okay.
It's remained one more point. Sorry. It's just about duplication of data. For example, we can use we can have a couple of people with the same name, but those are two different people. So how to separate one from the second one? So in storing data, it's much more easier to do than in Excel, for example.
Yeah, you're right. Thank you. And I think we answered the third question contemporary with the second one. Yes, why do we need to optimize data allocation? But maybe somebody wants to add something to the third question. We have a lot of people who keep silent today. Maybe you just join our discussion.
Can I answer for false question, please?
Yes.
Okay.
Alexei?
Good evening, everybody. The data stored in the database in the tables, specially organized, and we establish a relationship between these tables for convenient to operate with data.
Yes, great, thank you. I think the fourth question is fully answered, but maybe somebody will not agree with me and add something. Okay, so how could we link different tables?
May I, please?
Yeah, sure.
We can use special ID. So we have ID in one table and another table, and for linking information, we can use these tools.
Yeah, great. Maybe somebody remembers how we call these IDs?
This personal key, yes.
Primary.
Not
primary,
personal,
sorry.
primary key. Yeah.
I remember the first. A primary key is when it's in the. It's in one table, and when we link another table, it's a foreign key.
Yeah. So primary and foreign key. In IT different aspects of IT. We have a lot of different keys, like yes, personal or public, but in the database it is primary key. Okay, absolutely. And I see that everybody, at least those who answered the questions, read the textbook, and it seemed that everybody understood the material. Do you have maybe questions? Maybe somebody who keeps silent right now has some questions, and some material is not quite understandable, so we could discuss it right now. Alena?
Yes, I have one question. It's about differences between Excel and database. And the point 3 was that we can get the information from the other table even without linking the tables directly. For me, it's not clear. Maybe can you please say it?
Yeah.
other way.
Yes. I will try. I will try to show it, and I think I should show you this slide, for example, to explain it. So we here have exams table, yes, and in this exams table, as in your previous quiz, we have two foreign keys, yes. So student ID is a foreign key and teacher ID is a foreign key. But what if we don't want to know the teacher name that we could gather from this table, but we want to know what subject is this exam? Because here we have what we have. What do we have? Exam ID, information about student who passed or failed maybe this exam, the student ID, and we could gather the information about students from here, from this table directly by this ID. And teacher ID. And we can gather the information about teachers from here, from this table. But what if we want to know what subject was it? How could we know it? Of course, we could put another foreign key here, subject ID, and the information will be directly gathered from this table, subject, by the ID. But actually, it is not needed, because we could know about the teacher, and from this table, we could know about the subject, who this teacher is responsible for. So it is not needed to have here additional foreign key, because it is not beautiful. It is not according to the rules of creating the database. And we could gather here and then go here to the subject name. Okay. Is it understandable right now?
Yes.
Yeah, thank you, Alena. It was a really good question. What about other questions?
Good evening, Lila. I have a question about the subject ID. I understand, for example, about the student and the teacher, because we have different columns and much information, but subject has the only name of the subject. And in table student and teacher's table, we have the column with this ID, this information. So we have one cell with one information. Why we do separate table?
Yeah, excellent question, Svetlana. Thank you very much. Actually, for this artifactual database. It is not a real database. I just imagine it and put it to the materials. For this particular database, yes, it is really not needed because we have only one thing about the subject. And we could put the subject name here to the teachers table. But for this snapshot of this database only, because yes, we have some application maybe which is working with this database, and on this stage of the application development, we have only one field connecting with the subject, only the subject name. But what if during the development of our application, we will decide that it is needed to add more information about subject? Like, for example, how many hours do you need to complete the homeworks on this subject? Or how difficult this subject is? Or when the subject is added to the program of this hypothetical course, and so on. It could be added in the future. And that's why when we are creating this database, we think, what if we will update this database in the future? What information hypothetically will be needed in the future, and where this information will be stored? And it is better to have the database maximally optimized in the beginning of creation of the database, because to add a new column to subjects table, it's not very hard. It is pretty easy, and it will not affect the application much. But if we will need to add a new table and to restructure everything, to create new relationships between the tables, it will be the architecture update, and it will be pretty hard to do it. And that's why we decided to separate the information about subjects to the separate table, just for the future.
Thank you. And another question
Yeah,
to continue.
Please.
Are there any standards of amount of fields in one table for comfortable work? Maybe 5 or for example, here we have five fields. Mm-hmm. Yes. Is it some practical of amount? Usable amount of fields.
Okay, we have no such rules or restrictions about the amount, so the database should be optimized. It should be normalized. Mm-hmm. Everything should be in the most optimal way. And if we have a lot of information about one object in one table, it could be 10 fields in the database, or I don't know, 20 fields in the not in the database, in the table. It is okay. Mm-hmm. So there are things that database developers are thinking about. Is could we separate this information in one table? Maybe this is the information about some other object, like about the subject here. And if it is, it cannot be separated, it is about this particular object, it will be stored in this table, and it is okay.
Mm-hmm. Okay, thank you.
Mm-hmm. Thank you. Very interesting questions, Svetlana. Thank you very much. Anybody else?
Yeah, can I ask a question?
Yeah.
I have a question about keys, especially about super key and candidate key. Could you make an example maybe of it? On this example with students, maybe.
here we don't have a super key and candidate key actually, because here we consider only primary and foreign keys. And this interesting question as well, and probably I will prepare some special material for you for the next time, if you don't mind, okay?
Okay.
Yeah, because it is like a separate thing to discuss, and better to have some special time for it. Okay, I will put the notice. I will think how to explain it on these tables, okay? Candidate and super keys. Thank you.
May I?
Yeah.
Do I understand it correctly that the first column, example, exam ID, student ID, is called like a primary key, right?
Yeah, right.
In okay, so okay, I forgot the question. I'll
Okay.
ask later. Okay.
Okay. Thank you. Thanks anyway. Anybody else?
I have a question. So primary key must be always in the first column?
No. But it is more convenient to read the data when it is the first one.
And I have another question. If I understand correctly, student ID, for example, would be a primary key for students, but foreign key in exams table.
Yes.
So the primary key would be primary only for one, for example, table in the all database. Is it correct?
Yes, it is a primary key for the particular table with information about this particular object, like students here in your example. And to link the students table with some other table, we give that IDs and put to another table like exams. And there, that the same IDs will be in the column foreign key for this table. Yes.
May I ask a question? How
Yeah,
exactly the key looks like? Because, for example, if we can say like this cell is a foreign key, okay, probably by the name of the column, the machine will understand that it should look in the, for example, from student ID column in exams table to the student ID in students table. But for example, how does it understand that favorite subject should look in the subjects table, but because the column is named favorite subject instead of subject ID?
Actually, it is not mandatory to have the same names, just for your comfort. And how the machine will understand it, we will try to understand this in our next classes when we will try to use this SQL language. Because when we will write the requests to database, we will say here that please search this information here in this table by this field. So it is not mandatory to have the same names, actually. And the machine will look not by the name, but by your request. that you will generate for the machine.
Okay, okay, so it's purely by the request it is it is sent that it is a foreign key or a primary key, and where it should be looked at.
Yes,
right?
yes, exactly.
Okay, thank
Yes.
you.
Yes, it is just better for make the database more understandable to have this similar, at least similar names, not the same names. More readable, more understandable, but it is not mandatory.
So the one table can have only one column with the primary keys, right?
Yes.
Just one, but we can have as much foreign keys as we can imagine, right?
Yes,
Okay.
right. Okay. Okay, I think it is time to go further to the types of relationship between the table. And I hope that the material from the textbook is more or less understandable right now for everybody. If you have more questions, please feel free to ask on the next slides. So we've discussed everything, and we've it seems that we've remembered the material and understood more or less. And now it is time to go to the types of relations between the tables, because we know for now that tables could be linked between each other, and the information could be related some way between in the database between tables. Okay, so let's discuss the types of relations, and let's begin with these questions. The first one: how many students could every teacher have? Please answer one or many.
Many.
Many. Yeah, correct. And how many teachers could every student have?
Many.
The same, many.
Many, okay. How many subjects could every teacher read?
One, if we believe in the table.
Okay.
According to this, sorry, are we working on this database, right?
Yes, we are working with the same database so far. Yes. Okay. How many teachers could be assigned to one subject?
One.
Yes, correct. How many exams could one student have?
Many,
yes. And how many students could come to the same exam?
Many.
And how many subjects could one final exam have? Maybe strange questions, but
one,
yes. But I actually I didn't imagine how to phrase it in a more understandable manner. How many final exams could one subject have? Okay. How many?
One.
And how many favorite subjects do a student have? One. According to this database, one. Yes. And actually, we now thought and discussed the types of relations between entities, between objects in the database. What are entities actually? The entities that we have in the database are the objects that are described in the database: students, teachers, subjects, and exams. We have three entities there. And the types of a relationship between entities could be three. So could be three types of relations between the entities. The first one, one-to-one, one-to-many, the second one, and the third one, many-to-many. So let's begin from the simplest one, 1-to-1. One exam covers one subject. One subject, one exam. So this is the type of relation 1-to-1. If we have one-to-many teachers and subjects here, one teacher could potentially, not from the database, but potentially one teacher could read many subjects. And one student has, okay, one favorite subject here. This is the incorrect place in the presentation. Okay, so one-to-many is the teachers to subjects. And all the other relations are many-to-many. One exam is attended by many students, and together with this, one student attends many exams. One teacher has many students, one student has many teachers. So 3 types of relation between the entities in the database. And depending on the type of relation, we will organize our database differently. So the same picture, but instead of entities, we have tables here. Students, teachers, subjects, and exams. If we have one-to-many, one-to-one, let's begin from one-to-one. If we have one-to-one relationship between entities here, exams and subjects, one-to-one, it doesn't matter where to put the ID. So how to link the tables, because this is the one-to-one relationship, and we could link the tables anyway. Put the subject ID to the exams table or put the exams to the subject. But here we have the subject in the exam table. If we have one-to-many relationship, we should put the one ID to many tables. Here we have ID of subjects in the teachers table. And the most complicated thing is many-to-many. To organize our database in normalized manner, is in the most optimized manner, and according to the rules of organizing the database. If we have many-to-many relationship, we should have the separate table that will, in most cases, will contain only IDs of the entities that are connected by many-to-many relationship. So here we will have a student-teacher table with 2 IDs only. And how will it look like if we will apply all that rules to our database? So we are now continuing the optimization. Let's see again to the optimized database here. So we have teachers table and subjects table. Potentially, one teacher could be responsible for different subjects, like in our current course. For example, me is responsible for databases, test design, and test documentation, and agile, so 4 subjects. And here I added one more subject to Professor McGonagall, now she's responsible for chemistry as well. So this is one-to-many relationship. So one teacher is responsible for many subjects, but one subject can have only one teacher. Is it understandable for now, or you have questions?
Lilia, may I have,
Yeah.
may I have a question about teacher table? Can we enter in the subject ID column many IDs? For example, 1 and 2.
No.
If teacher can read several subjects.
No.
And how we should we do then?
We should add one more row here, one more line, like this in this table. So maybe I will step ahead a bit because this is your advanced task for this particular lecture about the normalization of tables in the database. The process of Alena, please. I will complete this speech, and then please feel free to ask a question. Okay. So the process of optimization the database called normalization, and the normalization of the database is going step by step, and there are so-called normal forms. And we say that the database is in first normal form, or in second normal form, or in third normal form, and so on. Totally, we have 6 normal forms. And this optimization is going step by step. And the first step of this optimization is avoiding such things like two values in one cell, like in the question that Dmitry asked. So it is absolutely restricted for the database to have more than one values in one cell. And if we have it, this is the contradiction with the first normal form. And without the first normal form, we cannot create the database, because this is the first step of optimization, and it will not work if we will not put the database to this first normal form. It will not work at all with the application. And that's why if we have several values for one object, like here we have one teacher and several subjects, we should add a new line here in your row with another subject ID. Did I answer?
And when we add another row with the same ID of the teacher?
No, the teacher ID will be different, like here. So please take a look here in this table. What do we have here? We have 2 rows for Professor McGonagall, the first one and the fourth one. And the idea is this teacher ID is not about like the names only. Not about the teacher first name and teacher last name. This is about the whole row. So, and we have different information here. We have the information here that the name of the teacher is Minerva McGonagall, and she's available from 10 to 11 a.m. daily. And the subject ID for her here in this row is biology. But in the fourth row, we have the same information regarding the names, of the teacher, and the available hours are the same as well. But this is the information about the other subject, about the fourth subject, which is chemistry here. And that's why we need the other row, and the ID of this row will be 4, not 1. Okay.
I understand. Thank you.
Okay, thank you very much. Alena?
Why we put exam points in this connection table? I can understand it, but is it any rule, or it's logically, but has it some rules?
Yeah. Actually, for the exam point, there are no rules. I put it here as an example that auxiliary tables could have additional information. And to understand why exams points are put here, maybe we could start from these two fields, a student ID and exam ID. Okay. So this is the many-to-many relationship. We have many students for one teacher exam, for one exam, and many exams for one student. So this is like one-to-many, but in both directions. This is the idea. One-to-many in both directions, and this is many-to-many, and that's why we need, according to the rules of database creation, we need this auxiliary table that typically we'll call student exam, student-exam. Yeah, not dash, underline, student underline exam, and this will be the special table for saving information, what tables are connected, what tables have that many-to-many relationship, and how are they connected. They're connected by student and exam ID. So okay, and we could, from this auxiliary table, we could go here to the exams table and get all the information about the exam, or we can go here to the students table and get the information about the student. And actually, in most cases, in that auxiliary table, we have only IDs. So this is completely auxiliary table with the IDs only, just to underline that this is the many-to-many relationship. So we should have that auxiliary table. But in some cases, we can put some additional information that is related to both tables connected with many-to-many relationship. We can put it to this auxiliary table to create one more field here and save it here. When, for example, we are not sure to which table this information is more related. So this is the exams point. To which object exams point are related? To the student, because this is the points that a student had on the exam, or to exams, because this is the point for the particular exam. So where should we put that exam point? Which way is better here? To the students table or to the exams table? Maybe to the exams, yes, because yes, this is the information about the exam. We have the subject ID here. Student ID is going here to the auxiliary table, but it is more like more beautiful or more optimized to put this information that is related to both objects to the table which is related to both objects. And it is very easy now, having this exams point here in the table, it is very easy now to get the exams points if we want to know something about a student. We, for example, generating a journal for the student, and we want to know about points. Or about the exams, like we are counting the average points for the exam. And if average points will be lower than, I don't know, 50, maybe something wrong with this subject, maybe something wrong with this teacher. Why the teacher cannot teach students if everybody has points lower than the middle one. So we could get any information because we have exams point in this accelerate table.
So we can add columns like exam points just for a case, because we may need it in future for work. So we can add like almost whatever we think we will use, right?
Right, if I understood well.
So we can add columns like this one, like exam points, if we think that it may be useful for future work, right?
Yeah, correct.
So is it easy to change then in the process, or it's not easy to change actually? Like if you want to add something else, one more column in some time, like in future, is it easy, or it is better to do it just for a case on this stage?
If we are sure that it is better to have the exam points here in the auxiliary table, we could put it right now. So in the future, we could make broader, and we could add more columns here. It will be easy. Yeah.
Okay. Thank you. And what about the in the first table, the column named course? Can we make another table with course IDs? Right?
Yes, right. We can do it, and if we have some additional information about the course, like the description of the course, some, I don't know, overview of the subjects in the course or something, we definitely will separate this course from this.
Okay.
Yeah.
Thank you.
Okay.
Can I ask a question?
Yeah, sure, Alna.
Do I understand correctly that the obligatory property of the auxiliary table is it has only foreign keys? It may never have a primary key inside. And it may or may not contain some other information which is not a key of any kind.
Yes, correct.
Okay.
Any other questions? Okay. So it's time to ask your questions. My turn to ask you questions. So check yourself. Just to make everything understandable, we will have such breaks inside the lecture to make sure that everybody understands everything. So what types of relations do you know?
One-to-one, one-to-many, many-to-many.
Who can give one or two examples of each relationship from a real life? except students and teachers?
Or one to many, for example, one sales manager and many clients.
Mm-hmm.
Many to many.
Maybe when many managers work with many clients, like is this like many to many?
Yes, if one client has many managers during
Like when
the process,
when they can work with whoever they want, they can change managers. Is that works?
yes, it works. Other examples, maybe?
And one to one, it's maybe yes, the personal when a client has a personal manager, so one to one.
No, because this the personal manager, I think, has a lot of clients.
Yes.
Maybe this is like very luxury.
Very
when a personal manager works with only one client, very luxury.
And wife probably.
Personal driver.
Some personal service, yes, personal driver, personal assistant with a chief.
Yes.
Husband and wife.
Okay.
Many companies and many job seekers, for example, when
Yes,
the job.
yes, yeah, good example.
One to one, maybe some person and his document, maybe the number of driver license.
Yes, yes.
Some personal information.
Some personal information, yes. Social number, yeah. Not a passport, because it is one to many. One person can have several passports during the life, but some social number, maybe the unique one. Okay.
Or the phone number as well.
One to one or one to many?
One to many.
One to many.
One person can have a few home phone number, phone number at office, and mobile number. Actually, about any kind of contacts, we can say so. One person and many contacts.
Yep.
Email and so on. Home address.
Okay, great. Seems that everybody understands the idea of relationship. So how do we connect tables in case of many-to-many relationship?
With the additional table, which include foreign keys.
Yes.
Foreign keys of two other tables, which is related to this additional table.
Yeah.
Lydia, one question about this extra additional table between many to many relationship. This table should contain all relations one to one. Yes. For example, we have 4 students and for example 4 students and 4 teachers, and they have a relationship between. So in this additional table, we should write how many? 16.
Yeah.
16. Yes.
Yes, yes. If all the combinations are valid.
Each combination, yes.
Yeah, each combination, each valid combination, because if we have 100 teachers and 100 students, it doesn't mean that each student related to each teacher.
Yes,
Maybe
of course. Only according to situation.
Yeah.
If they have some relationship, so we should put it.
Yes. Yes.
Okay.
Exactly. Okay.
Thank you.
Okay, guys, we are learning for 1 hour. Do you need a break? 5 minutes or something?
Yes, I need if possible.
Okay, so we could have a break right now because we are going to the next topic, ER diagram. And see you in 5 minutes.
Okay.
Okay. Okay, so our next topic is entity relationship diagram, ER diagram or ERD. So what does it mean? What is this diagram? Please take a look on this slide and tell me what does it look like and what is the difference between this picture and the previous one. The previous one means this one. Take a look here. And take a look here and find 10 differences. Maybe not 10. So what is the difference between?
I think it's look like previous tables, but it contains some, as I understand, connections between different tables, and it shows what we should enter in different cells, maybe.
Okay, you're right about the connections, but I didn't quite understand about the cells. Alexei, okay.
On the first picture, there are relations only, and in the second picture, there are type of relationship between any case.
Yes. Okay, you all are absolutely right about the relationships and about the types as well. And what else? What other difference can you see here?
It shows data type of
yes,
that,
data type, and we will state on the data type a bit later today. What else?
Also, the requirements for the cell to be right. I don't know. It's, not now. It's a requirement, I think.
Yes, yes. You're right. But everybody is talking about the cell. Is it a cell? Or maybe you have other versions? What it could be?
Column, maybe.
Yes, yes. This is a column. This is the other representation of the database. What do we have here? We have the tables, the same tables: teachers, students, student teacher, student exam, okay, points, exams, subjects. All the tables are absolutely the same, like in the previous picture. But in the previous picture here, we had the data inside the tables. We had the information that is saved in the tables. But what if we have a lot of information in the table? Here we have only 4 rows. Here we have 4 rows as well. 4 rows, 5 rows, 4 rows here. But what if we are not talking about 4 rows, but 4,000, 4 million? How could we display everything in one place? How could we understand all that relationship if we have so huge tables? And this is absolutely a real situation. Because we have the database, we have a lot of information in the database, typical for the application. And that's why we need some special schema, some special way of representation of the database, where we will not maybe have the information that is stored inside the tables, but we will have the information what is the table about and how does it relate it to other tables, what relationships do we have, what primary and foreign keys do we have. And for getting the impression about the database, for getting the understanding how all that are working is enough. And that's why we need this diagram. So this is the diagram with tables, the columns, what does the column call, and as you absolutely right answer it with the information about some restrictions that not null, and the data types. So this schema is called entity relationship diagram, ER diagram, or just ERRD, 3 letters abbreviation. Okay. To sum up what ER diagram is and what is for. It shows schematically tables, their fields and keys and relations between the tables. This is entity relation diagram. Why entity relation? Because we can see the entities there, what objects are stored in the database. And here there are student, teacher, exam, subject, all that are entities. And how are they relate to each other? What type of relationship do we have? One-to-one, one-to-many, or many-to-many? So we have, as you probably already noticed, we have different errors here between the tables. And here is one-to-many, yes. Here is many-to-many. Different types of relationships. Here, primary public here, I forgot to correct. Primary and foreign keys are shown here as PK or FK. And you can see that PK doesn't have any number, because this is the unique key and we have only one primary key in the table. The foreign keys could have numbers like here, foreign key 1, foreign key 2. And like here, but it seems that it doesn't show in the full screen mode. Okay. Any questions about the relationship diagram? Entity relationship diagram. Maybe I will switch back to this slide to make you more motivated.
And how should we show one-to-one connection?
One-to-one connection is like just a line without any. Typically, just a line without any things, additional things. Okay. If no questions, this is my turn to ask you questions. So how did you understand? Why do we need an ER diagram?
May, as I understand, to show maybe the structure of the database and, also to show the format of data format and the relation between the different tables.
Okay, thank you. And Dmitry asked to the first and the second question. What is it shown on in ER diagram? Okay, so how is a public key shown? Who can tell me?
The
PK.
PK, yes, and foreign key?
FK.
FK, primary key by public. Okay, and we probably completed with this topic for now, because we will return to the entity relationship diagram in the end of the lesson. And now it is time to discuss the data types. So let's return to this picture, to this diagram. What does it mean? Integer, char, date, what do you think?
I mean, a char is a type of data. They are string data. Char may be from word characters, and it is restricted by 50 characters, maybe.
Okay, thank you. Does anybody understand? Everybody understands this idea? Because Alexei, I think, is familiar with this topic. Or it is needed to explain. What is it?
Yes.
I think I
Yes,
understand.
please.
Yes, please. Okay, I will. So, while working with a database from the application, we should have some rules how to work with different type of information. Like we could have the numeric information, like we have we are working with exam points. And our application will know that this is a numeric thing. And for example, we could count the average of points, or we could count the number, how many students have the points lower than 50. Or we could multiply these numbers, or we could add these numbers, or we could divide these numbers, because we are working with numbers. And from the other side, the application could work not only with numbers, but with strings, with dates, with other types of information. And if it is working with date, we will know that okay, this is a date, and this is a date as well, and this is a date in the future, this is a date in the past. So this date could not be less than this one, because our application is working with different type of information differently, like we in our real life. So we will not multiply strings. We will not, I don't know, find the substring in a date. It is in most cases not needed for us. So the same for the application. And that's why we should tell the application what type of information is it. Is it a string? Is it a number? Is it a double number? Is it a date? Is it a time? Or some other types, like some, I don't know, a link, for example, to some kind of resource. And these different types of information should be saved in the database differently. So we are beginning from the lowest level of the application, from the database, to distinguish different types of information. And that's why we have that restrictions for the field. We initially, when we are creating the database, when we are creating the tables in the database, we say what type of information will be stored here in this field. And we say here, let's begin from teachers, for example. Teacher first name and teacher last name. They both probably strings, yes? For working with string in the database, we could have different approaches, different types of fields. But here we have char 50. What does it mean? Char, as Alexei already said, means character. This is from character word, char. It means that here we will put string that includes characters. And this number in the brackets means that the limited size of this string is 50. So we have maximal 50 symbols length of the string. If this string that we are going to put here is longer than 50 characters, it is impossible to put it here. So characters with a length of 50 symbols. Questions? And probably I know what the question will be.
Yeah, I have a question. Column, as I know, it's vertical.
Yes, no, not column, in the cell. Yes, sorry. Yeah. And
no.
in the column. So in the column we have the same type of values.
I'm talking about the difference of char and varchar.
Yes. So what is your question? What is the difference between char and varchar?
Yes, and as I understand, in that case, there might be varchar decided. Must be.
Why must be?
Because we're talking about length of name and surname. No?
So var means variable. So
yes.
we have we could have different lengths here if we have varchar. If we have char, we could limit the length of the string.
Okay.
Mm-hmm. So for the others, varchar is another type of string in the database. Char is a limited string, limited by the length. And probably you will ask me why should we have this limit, or is it understandable why we could have a limit by length?
Why?
So you need the explanation, yes?
Yes.
Why do we need
Yes.
it? Okay, so this is for making the database even more optimal, because it means that we will not put here very long strings. There more symbols we have in the string, the more difficult to process the string. Maybe in contemporary application, it is not very critical, of course, because we have like very fast machines right now, and we have very fast connections. But if we are talking about not so contemporary applications, or if we're talking about not so fast networks, not so fast internet, it could be critical to economy some time of processing some information in the database. And that's why if we sure that it is with a great probability will not be longer than 50 symbols, because here we will save the first and last name. Can you imagine the last name that will be longer than 50 symbols? Maybe some German last name, I don't know, but I'm not sure. I think 50 symbols will be enough for it. So the char processing is faster than varchar. And that's why if we are sure that our string will not be longer than some particular number of symbols, we are better to use char, limited string, not variable, not varchar.
So is it correct for just my understanding that when we set some limits, we going to save space for data storage, just because every symbol engage some space of memory, and it helps to save more available space?
Yes, you're right.
Okay, thank you.
Okay. Is
May
it
I ask?
Irina?
In the line, what does it mean? Int related to what?
Int related to
Exactly in this.
integer. This is a number, not a double number. Integer number like 1, 2, 3, and so on. This is a positive integer, and could be a negative integer like -1, -2, and so on. And the type is called int. Date means date. We could have a date like in exams table. Okay, maybe I will do like that to show you the whole picture. Here we have a date, exam date, type of date. It could be different other type like date time, like double, double means a number with a point, with a dot inside. 1.5, for example. And dates and date time are the same as the name. So if we are going to store a date in the database, the type should be date, to say our database and application how to work with this column, with this type of values.
So is it the same like types using for programming, like Boolean, integer, string, etc.?
Yes, more or less. So the idea is the SQL is a programmer language. Maybe it is not so useful and for some operations like Java or Python or something, but it is a programming language, and some basic principles are the same for SQL and for other programming languages, like divided into data types. Okay, so what do you think? What is not null? What does it mean?
Not empty.
Sorry?
Not empty.
Not empty, yes. And what does it mean?
The cell connect data, or the cell contain data.
Okay, so our subject ID contains data as well, but it is not null. What is the difference? Who can guess?
Zero.
Anna, could you please repeat?
It probably shouldn't be zero either. It should contain exact type of data, like it should be contain the int and should be empty and should contain zero.
Okay, closer, but Alexei?
Okay, maybe not null. I mean, the cell should contain not empty, maybe not empty, and contain only data according data format, data type. I mean.
Okay, even more close to the truth. Okay, so attention, right answer. What is not null? Firstly, it shouldn't be empty. So it is impossible to create a teacher without a first name or last name or available hours. You cannot do it. You cannot add the information to the database if you will not assign the first, last name and available hours to the teacher. This teacher's creation is absolutely impossible. So this is the restriction on the level of the table. The system will check your new teacher, and if your new teacher will not have ID, first name, last name, and available hours, it will not be created. You will get an error. But you can create a teacher without a subject ID. For example, the teacher is just hired to the courses or to the university or to the school, and they for now, they don't know what subjects will be assigned to this teacher, and we can't create the teacher without the subject, but not without the first name, last name, and available hours. And of course, the ID. We cannot create a row without a primary key, and that's why our primary keys are always not null. And another thing that I want to explain right now, just to be on the same page, there is a difference between 0 and null. In programming languages, including the SQL and including the database creation language. So null is empty space. Nothing is here. It means null. And 0 is a number. If we have 0, it means that this 0 is put somewhere, and the storage is filled with this 0. So 0 is an object. It is a number. The same number as 1, 2, or 50. But null is not a 0. Null is empty space. Nothing here. Understandable, guys, folks, girls?
Yes.
Yes, it's clear.
Yes.
Yes.
Yeah. Great. So, wrong direction. Okay, we should be here. And this is to sum up all that we've discussed previously. Now, there are two tables, two examples of different data types. We cannot process different information equally, and that's why we should have the data types. That are the strings, the short strings char of char type. Yeah. And that are the numbers here, int type. And this is a date type. So we could have different data types in the same table, but we cannot have different data types in the same column. So every column should have only one data type. We cannot put a subject ID here, or we cannot put a number here. Or, okay, we could put a number here, but this number will be considered as a string. So what data types do we have in SQL? We already considered the char, means character, is a fixed length string, and it can contain letters, numbers, and special characters. And again, please pay attention that numbers there will be considered as a piece of string. We could put there 1, 2, 3, 4, 5, but it will not be numbers 1, 2, 3, 4, 5. It will be a string of characters equals to numbers. If it is understandable, I'm not sure, but I hope. And on ER diagram, we will have char 50 in brackets, where 50 is a limit for string lengths. For example, McGonagall from our hypothetical database. Varchar. Again, what is the difference? A variable length string. So varchar means variable length of characters. And it can contain the same letters, numbers, and special characters. On ER diagram, we will have varchar. And two examples here. It could be a short string, like here, the same, because it is not limited from the both sides, or it could be a long string, like here. It is a sentence, and we cannot put this sentence if I counted correctly the length of the sentence in symbols, we cannot put the samples a statement here to char because it is longer than 50 characters. Okay. Another type is integer, a medium integer number. The signed range is from -10 in 32 state. The unsigned range is from 0 to this number. So we could tell that it could be both negative or positive number, or we could tell that it could be only positive number. And that's, in this case, we will have from 0 to this number. On ER diagram, we will have int. And example is 1, or this character. This not character, this number. Float, a floating point number, 1.6. Date. Pay attention that you cannot put any date here in any format. The format of date is according to the rules, and the format should be year dash month dash day. No any other format. No any slashes between month and day, no any dots between days and months. Only this one. And this is the example. Date time. Date and time combination. The format of a date is the same as here in date format. And this is the format of time. Again, it should be only like that and no other variants of formats. Hours, minutes, seconds, date time. This is the example. And space between date and time. And the Boolean type, if we have a value that could be true or false, and that's all. It will be a Boolean type, and 0. Pay attention again, not null, but 0. 0 is considered false, and non-zero values, typically 1, are considered true. Do you have questions, especially regarding the Boolean type? Because it is very obvious for every programmer what is a Boolean type, but not maybe for people who are not familiar with programming.
Could you make an example with this?
Okay. Any example from the applications? If you have a check in the application, I agree with this agreement. Check. I want to have a lot of spam in my email. Check. When I registered it here. This is the Boolean. So we could have only 2 variants of value here. The checkbox is checked, or this checkbox is unchecked. No any other values. It cannot be partially checked, for example. It could be only check or uncheck.
Okay, thank you. And another question, what is the difference between varchar and text?
typically it should be varchar in the database.
Well,
Text is
can it
longer.
hold-
It's longer as
Can it
far as
hold
I remember.
numbers or it's the same?
It is maybe not the same. As far as I remember, the text is longer than varchar. But I'm not sure. It needs to be checked actually. There's a difference.
Yeah, thank you.
Lilia, cloud boolean type. May it contain only numbers or some symbols?
In the database, numbers, yes, 0 or non-zero values.
And about char type, has it some limit, maximum limit of symbols?
As far as I remember, 256 is a limit for char.
Thanks.
Lilia, can you clarify me about the integer, about the signed range and unsigned range? What is it? Maybe I missed.
By default, it is signed. And if it is signed, it could contain both positive and negative numbers. But you could mark that this integer is unsigned. And in this case, negative numbers will be restricted here in this field. Only positive.
Okay.
Thank you. Okay. Seems that no questions from your side. It's my turn. So who can explain me why do we need different data types?
To operate with data differently, depending what type is it.
Okay. What data types correspond to strings?
Words,
numbers, special characters.
But what data types?
Char.
Char?
Or varchar.
Varchar, yeah. Thank you. What about numbers? What data types?
Integer.
Integer, yes. What else?
Float.
Float, yeah. Yes. What about dates and time?
Date and date time.
Date and date time, yes, correct. And what type did I forget to mention?
Boolean.
Boolean, yes.
Boolean.
Is Boolean understandable for everybody?
Yeah.
Yeah, for me, yeah.
Yes, great. Great. Very, very smart group. And it is time to repeat everything on a real database, because the database we considered today was a hypothetical database that doesn't exist in reality. And now I'm gonna show you our database that is real. And we will try to understand the ER diagram here. Somebody has some problems with the connection to the database. Was the problems resolved? Or you have Some problems still. Okay.
We should connect with this database now?
No, it is not mandatory. Just I'm asking in case. You could do everything with me. You can connect to the database now if you have the dbeaver near you, and it is just has to be opened, and that's all. But if you didn't connect yet, it is not mandatory for this lesson. Okay. So this is the dbeaver, and if you already connected, probably you saw it already. And that are our databases that we will be training our SQL and databases on. We have 3 databases here, and now we are interested in this one, FTB underline ST00. For you is it is not 00, and ST for you is some username like here in the top of the screen. What do we have here in the database? We could press here, and here we have tables. This is a database of our FTB application about the flights booking. If you already read the general documents, probably you read about this application. If you don't, you can do it till the next lesson. These are the tables: aircraft, airport, flight, passenger, roles, users, and this additional table, users, roles. We could open the tables here, and we will see the columns and some other types of the datas here. And this is the AR diagram of the database. I'm not sure if you can see it well. Hopefully, yes. So what can you say about this database? What data do we have here? What relationships do we have here between the tables? What primary and foreign keys do we have? What data types? It looks a bit differently because this is how the dbeaver generated the schema. And the data types, for example, are shown a bit differently here. But I hope you can guess what is it about.
So we see a passenger, passenger ID, so it's a primary key. And flight ID, it's also another primary key.
In the passenger table, do you mean, or in flight?
Flight ID. No, aircraft. Passenger, it's truly primary.
Yes, in passenger table, passenger
Yes.
ID is truly primary key. Yeah.
Yes.
Without any doubt. Okay. What else do we have in passenger table? What is else interesting for understanding the database?
We have attributes with data types.
What data types do we have? Do you think?
String and int.
Yes, string and int. String is varchar, as far as I remember. here, and int is for the keys. So what is the foreign key in passenger table?
Flights.
Flight, yeah. The last one, flight ID is a foreign key. And with which table this table is connected to?
It's connected to, I guess, one-to-many relations, non-mandatory relations with flights.
Yes.
Table.
Yes, absolutely right. So we have flight and passenger, two objects with one-to-many relationship, many passenger in one flight. And the tables are connected by flight ID. And here you can see that, as I said previously, it is not mandatory to have the same names in two tables. We have flight ID in flights, and it is connected with the passenger table by flight ID, but we have a foreign key, flight ID here. Yeah. Okay. What about this table, flight? I think this is the most interesting table. What primary key do we have here?
Primary key is flight ID, and there are more foreign ID. For example, aircraft type, departure and destination airports.
Okay, aircraft ID is connected to which table?
Is connected which aircraft table?
Aircraft. And the most interesting right now, folks, departure airport ID. To what table is it? To what table is it? Is points?
Airport table.
Airport table.
They had primary key for this table is airport ID, and there are described all columns of this table.
Yes. And what about destination airport ID?
The same table.
The same, yes. So very, very interesting thing here. We have two foreign keys in the table, in the flight table, that point to the same table airport. So
why do we have two primary keys in airport? If I understand the small symbol correctly, it's airport ID and
this is a complex key. This is not like two keys. The complex key, airport ID and airport code. Two fields in one keys. One key. It could be.
I see. It's a different one sign. It's like tiny, but it's important.
Yeah. So we have, thank you, Anna. We have two interesting things in this database. When we have two foreign keys here in flight table that point to one airport table, of course, in the application, we are looking for two airports, the departure and destination airport, but it doesn't make sense to have two tables for the departure and destination airport. Absolutely doesn't make sense. That's why we are pointing to the same table to get the information about the airport. But we should have two airports for the flight because we have no other way to describe from where to fly and to where. We should have two keys here. And here we have the complex key, airport ID, and airport code. So this is the two fields in one key. And the same here, ID and email, and username, three fields in one key. And user roles is the additional table for many-to-many relationship.
Why we need this table upper? What for?
Which one? What do you mean?
User roles users. It's not connection with any other table.
Yes. If we have a database, doesn't mean that every table should be connected with every table. If we have no connection between users and flights, because the flights and passenger and airport and aircraft is about booking a flight. And users and roles is about who can open and who can do something with this application. Because we have the administrator role for the application, we have a passenger role for the application, we have a manager role for the application, and that roles are not connected with flights. This is a separate thing. That's why we have no connection between these three tables and these four tables. But we can put that two sets of tables into one database. It is not restricted.
Thank you. And what is this hibernate sequence?
Where?
Hibernate sequence, if I pronounce correctly.
It is a system thing. Every database have it. Just so. Don't pay attention to it for now.
Thank you.
Okay. And I'm not sure that our application will be opened for me right now, but I hope it will. Yeah. 2 more minutes, guys. I will just show you the connection between the application and the database, and then we'll complete our today's class. So this is our application, one of the applications that we will use during the whole course. This is about, as you can guess probably from the database, it's about flight booking. And I can show you how all that stuff is connected to the database. So this database that you just saw is not some separate thing that is hanging in the air, and it's not connected to any things that you are familiar with. It is connected through the APIs, through the backend. It is connected to the application. And the application looks like this. Here we can search a flight. This is the list of the airports. From the database, from a database table, this one, airport. And here, another list of airports from the application, not from the application, from the database, from this table. But we are booking a flight, and we are connecting now with this table. So when we are searching for a flight, we are searching firstly for the destination for the departure airport, and then for the destination airport by clicking to these two fields. From departure airport, this is the list from the database, and destination airport, this is another list from the database, and the lists are the same, as you can see here. And departure time, this is the field where we search. Okay, let me find something. I'm not sure in a date, maybe the result will be empty. I don't know. No records found. Okay, anyway, the departure time is from here, from this flight table. So by clicking that fields in the application, we refer to this database and we get the information from the flight table and from the airport table. And we merge this information together and we show it to the user. This is how the application typically works with the database. And in the next classes, we will see how to refer to the database. We will do it directly with this dbeaver tool. We will do it directly with the help of SQL or SQL. So better to pronounce SQL actually, but 3 letters are SQL. We will do it directly, but you will know that the same way our application refers to the database with the same, absolutely same requests to the database. But it will be next time. Hopefully you will read the next section of the textbook that is already put to the Moodle system. Thank you everybody for now. You are a very smart group, really. So many questions to you. I'm excited. Yeah, and I very appreciate your activity, guys. So please do it next time as well. And that's all for today. If you have no questions, we could stop.
Oh, we have advanced homework or something. From this lesson, we should have like third part, which is the homework.
Okay. Let me see. How does it call? Give me a moment to log in to the system. Okay, so you have the assignment. It called block number 02.4, Introduction to Relational Database assignment. And this is your homework for this lecture. So please do it. And as for this assignment and the other assignments that you will have, you have 2 variants of assignment, easy one and not so easy one. So if grade 4 is enough for you, so maybe this part of our course is not so interesting for you, it could be, it is okay. You could do only the first part of the assignment and get your 4 mark. But if you want to get 5, please do both parts of assignment, the easy one and the complicated one. Okay.
And what is the deadline?
2 weeks. This is the last deadline, but it is better to make it more fast, of course.
Thanks.
Your deadline is 2 weeks.